Welcome to another video for Stat 420. In this video we're going to talk about writing TeX in RMarkdown as well as writing inline R code as well in your Markdown. And so when I say inline code, what I mean is that you can actually directly write code in the white space of your RMarkdown file so that you can kind of reference code output directly in any of the text that you might write. I have an RMarkdown here. We're going to start with TeX and also just kind of a brief introduction to what that is. You might have heard LaTeX instead of TeX. TeX is kind of like the language itself, whereas LaTeX is kind of the common software that a lot of folks use for writing TeX. So for an RMarkdown, we might better say that we're really writing TeX, but LaTeX is probably going to be the key word that you would use a lot when you're kind of Google searching things. That's what most people kind of call it at this point. So LaTeX is really kind of some macros that exist on top of TeX. It's kind of a compiler for producing TeX documents. So it's a little bit kind of like RStudio is to R, where RStudio is kind of like the IDE. It's the way that we kind of interact with R, whereas R is the language, so kind of a sort of similar relationship with TeX and LaTeX there. So LaTeX is whenever I'm writing symbols, in particular, usually a lot of mathematical formulas and things, and I want to use the proper kind of notation. And the way that I would start to do that is with dollar signs. So if I write dollar signs, then anything that I put in between, RMarkdown is going to recognize as TeX code. And so, for example, I could write x equals 2, or, well, that doesn't quite work. There is x equals 2. And you'll notice that if you hover over it, you'll see kind of a preview of what it looks like. And obviously, I could write x equals 2 out here as well. I won't get kind of this pretty script x when I do that, but just kind of an example here of, I can write things in here and get it in that kind of that mathematical notation. But TeX really comes in handy when I'm writing symbols that I don't have on my keyboard. So for example, if I want to write a beta symbol, I can do that like this, where I use kind of that backwards slash line. I guess it's called a backslash. And it's probably going to be above your enter or return key on your keyboard. And then depending on what you write, there's a host of different kind of symbols and commands that are associated with this backslash. So in this case, if I write beta, all in lowercase, I will get a beta symbol. So it is case sensitive. If I write capital beta, it's not going to do that for me. So it does need to be lowercase beta. And I can do this obviously for lots of different symbols. So all of our kind of usual suspects like sigma or alpha or mu or anything like that works here as well. I can also do subscripts as well. So if I just do an underscore, then anything I write will be a subscript. If I have multiple things to put in my subscript, so if I want to do that for some reason, I can do that with the curly braces. So, or I guess people just call them braces typically. So braces are often used if I'm kind of doing a subscript or a superscript, or in a couple other situations where I have more than one thing to write in that kind of subsection of this kind of outer command. All right. So something you might commonly write would be maybe writing a null hypothesis that beta 1 is not equal to some value. So not equal to, by the way, is a symbol. So since I don't have it on my keyboard, I can just do the backward slash, and then any q happens to be the code that I would write to get that particular symbol. So at this point, you might be wondering, how do you know what to write for different symbols? You can kind of learn along as you go, but you can always look up a lot of this if you just kind of do a Google search for something like LaTeX symbols. And this is a site that I typically go to that just has almost everything that I'm ever looking for, all the Greek letters, a lot of different things, symbols here. So you can probably find what you're looking for by doing a quick Google search. But we're not necessarily going to be doing a lot of fancy things in this course, just kind of some very basic code writing here and there. Now, fractions are a little bit more complicated. So if I wanted to write a fraction, for example, maybe I would do frac to kind of set up the front there. And then I'm going to need two sets of braces, one for the numerator and one for the denominator. And so maybe my numerator is going to be x equals 1, and my denominator is going to be n minus 1, or something like that. I guess x equals 1 doesn't make any sense. We'll do a plus. So that's how I would do a fraction. It's just with frac followed by two sets of braces. I can also do a summation symbol. So that would just be sum. And then if I need to do kind of a subscript, so for example, from I equals 1, I can do that. And I can also do a superscript with kind of the caret symbol there. So then if I just doing like I equals 1 to n, I would just do n. If I needed to write more, I could put it in braces, but typically this is what we're often doing with summation symbols. So if I wanted to put that all together, maybe I want to write the formula for the standard error of the residuals, kind of our approximation of sigma sub e, the true standard deviation of the residuals. I could do that. So I would probably need to start with the square root, which is sqrt. And then inside, I'm going to have a whole bunch of things going on. So this is going to get a little complicated, so I'm going to give myself some space to see what I'm doing. So number one, I'm going to need a fraction. So I'll do my numerator denominator there. And my denominator, that's going to be easy. That's just going to be n minus 2. Oops. N minus 2. My numerator has a couple things going on. This is going to be the sum of these squared residuals. So I'll start with the sum from I equals 1. And I guess I don't really need the spaces. It doesn't really matter. I equals 1 to n. And then followed by my squared residual, so y sub I minus, and then you can do a hat here. So hat is also going to be a symbol. And then inside I'm just going to do y followed by a sub I. And then if I want to square that, I can put a square outside those parentheses that I set up inside. So obviously there's kind of a lot going on here, and you might be looking at this like, whoa, you know, that's a lot of stuff to write. And in this class, we won't make you write a whole lot of complicated tech, just kind of a few things along the way, and certainly we start very small if you're asked to write something. But these are all things, like as long as you know these kind of basics, you can probably kind of figure your way out to these more complicated expressions or equations. And certainly the code previews help to make sure that what you're writing is doing what you think it's doing. One other thing that might be helpful here is that you can also do kind of a double $sign if you want to write something that's centered and usually a little bit bigger as well. So if I wanted to take this whole expression, but I want it to be bigger, I can do that. And if I go ahead and knit this, by the way, you can kind of see what the difference is between these two things. So it will take just a second. This kind of stuff usually goes just a little bit slower when I have my recording going, but you can kind of tell there, maybe it's hard to tell. Technically, the one that's centered is a little bit bigger than the one that's kind of inline text. So if you wanted to write something bigger and kind of pronounced, you can use the double $sign there. I also want to talk about inline R coding because that's going to be helpful and something we're going to ask you to do moving forward in a lot of places. So let's say that I'm working with the CATS data again. So I'm going to kind of call that out, and I'm going to make a model with birth weight being predicted by heart weight. And so I can kind of define this model here, and now it exists. And you might be used to kind of, doing a summary of the model or extracting, the coefficients inside, and I can certainly do that of, the coefficients of my model. I can do that. I can call on a particular coefficient like the intercept, or I can call on the slope, and I can get that output. And obviously I can write down here, maybe I'm interpreting, the slope is, let me get rid of these previews. It gets kind of annoying after some time there. The slope is going to be that 0.16 value. And notice one thing here is if I don't want to necessarily round. The other thing that's kind of annoying is that if I made a mistake or I need to adjust this somehow, I'm going to have to adjust my text as well. So it's nice if I could just kind of link this directly to code. So what I can do here is I can do these tick marks, start with an R, with an R there, And then I can just write the code that I want to extract. So I can write coefficient of model and then brackets. And then as long as I'm surrounded by tick marks with an R in front, R is going to recognize this as inline code. And when I go to knit this, you won't see it when you're typing it. It won't give you a preview. But if I knit this, you'll notice that that number does show up there, right? So I get this point 1602902 directly into my inline code, which is really, really helpful kind of moving forward. So we'll be doing a lot more of that as the class kind of goes on. Again, it's annoying that you can't see the preview necessarily in your code, but you can always kind of check it, obviously. Like if I read it in a code chunk, then I know that my code worked, and then I can just kind of push it over, and I'm pretty confident it's going to work when I knit my document.